we've looked at how to do U substitution with indefinite intervals, but now we need to look at definite intervals. So let's start by doing like we would always do, U and du. U is going to be this 5x cubed minus 1. That way du is 15x squared dx, and that's what we want to be able to try to cancel this out. So if I were to try to solve this, I would say the integral, I would have the 15x squared times u cubed. Dx is now 15, it would be du over 15x squared, which means that my 15x squared would cancel out like I would want, and I would get the integral of u cubed du. Now, here's the thing. We're talking a definite interval now, from 0 to 1. Well, this is when x was 0 and x was 1. We're not talking in x anymore. We're talking about u. We need to know what u equals now for both of these. So how do we figure that out? Well, like so. If x was equal to 0 in this, I could solve for that to figure out what u is. When x was 0, that means that u would be 5 times 0 cubed minus 1. So u would be minus 1 there. And then I could also say when x was 1, as it is up there, what would u be? Then you would have 5 times 1 cubed is 5, minus 1 is 4. So u would be 4 here. So my new limits are -1 and 4. So from there, what I would look to do is just solve it the rest of the way like I normally would. I would now take this integral. It would be 1/4 u to the 4th, and that's from -4 to 1. Or -1 to positive 4, I mean. So now I'd be plugging in 1/4 of 4 to the 4th power minus 1/4 of -1 to the 4th power. And when I do that, I should get 256 over 4 minus 1 over 4 and get 255 over 4. So that's how you can get a definite integral. Now that's just one option. There is another potential option you can take. I'm going to start this the exact same way, so I know what u and du is now. I'm going to write this in green with this option 2. We would take the integral, we still have again 15x squared times u cubed, and this will be now du over 15x squared. So again, we're going to have these canceling out and giving us the integral of u cubed du. Same thing we had before. Now, my question again is, what are these limits? What I'm going to say right now is, honestly, I don't know, and really, I don't care at the moment. And I'll show you why. This is what we're going to do. We're going to evaluate the integral like we did before. So it's, again, 1/4 u to the 4th. Again, from I don't know to I don't know, because I don't know what u is. I have to plug in, and sometimes that can get messy. So what I'm going to say is, I'm going to first put this back in terms of x. And I'm going to have it be 1/4 of, it would be 5x cubed minus 1. And that I'm evaluating, for the x's, I'm evaluating at 1 and 0. Because this is what x equals, which is what my problem was in the beginning. So when I do that, 1/4, by plugging 1, 5 times 1 is 5, minus 1 is 4. So it would be that to the 4th power. Minus, by plugging 0, I would get 1/4 times 0 to the 4th power. Or not 0 to the 4th power, it would be instead not 0, but -1 to the 4th power. And that's the same as 256 over 4 minus 1 over 4, which is 255 over 4. Now let's look. This is going back here in blue is option number 1. Look what you had. You plugged in, you got 4 and -1. That's what you were raising to the 4th power. 256 over 4 minus 1 over 4. With the second option, same thing. You ended up with 4 and -1 being raised. 256 over 4, 1 over 4. Either way works just fine. If you feel comfortable in being able to change like you do in option 1, if you feel good in changing it, here's option 1 with changing your u and x and changing your limits. So go ahead and change your limits if you care, or if you think you're good with that. Otherwise, the way I prefer is I sometimes forget to change the limits or think I might do it wrong. So option 2 is just to get it back to x first. And then you can have your limits. So it doesn't matter what these limits to change into if you change it back to x first. Either way works fine. It's whatever